Hello, everyone. This is Terrence Parker, and thank you for joining this Jinlong Technologies Solis Inverter hosted webinar. Today, I'll be speaking along with Ezekiel Ferguson from SnapNRack and Bill Brooks from Brooks Engineering, and I'd just like to welcome you all to the webinar. Thanks for joining. If you can see my screen there, Solis Inverters, you can see our product line there. We have a three-phase inverter with that really cool 7-inch screen there where you can actually do charging right there on the screen. And then you'll also notice our single-phase inverters there, and the smaller box is our rapid shutdown device. And we were showing these products at the NABCEP CE Continuing Education Conference here in Dallas this week, and it was great seeing the NABCEP installers and showing off the product. So we are going to focus today on some inverter stuff, but really we're going to focus mainly on rapid shutdown and how systems get certified and you can get in compliance with using these devices and using them properly. We'll also be talking about how the SnapNRack mounting system solution helps installers make this happen and helps installers get in compliance with the National Electric Code as it's written today and going forward. Today, again, my name is Terrence Parker, and you can reach me at that email there. I work for Jinlong Technologies, and we produce the Solis inverter. So that's the Solis is like our brand name. And we also produce the Solis Rapid Shutdown device. We're joined today by Bill Brooks. You can see his I'm not sure that I got your email address correct there, Bill. I think it's brooksolar, actually, .com. And then Ezekiel Ferguson over at SnapNRack. And thanks, guys, for joining me. I really appreciate it today and look forward to hearing you speak. So just as an introduction, Jinlong Solis, we are a global player. We have 25% market share, for example, in England, and we distribute in the Netherlands and Spain and Germany. We have a market presence in India and Australia. And we are now, we have brought the U.S. product to the market back in 2011 or so, and we started getting our certifications and getting on the approved vendor lists and that sort of thing. And so we started distributing the product in 2015, and we had a pretty good year in 2016. Currently, we're about 5th place in the market here in the U.S., and you can see that we won the top brand in England in 2016, and we again were rewarded this same award by the EUPD research group for 2017. So we're very proud of that, and that's just a general overlook of our company, and kind of famous for its reliability and cost effectiveness in these string inverter systems. Next, I'd like to introduce Bill Brooks, and Bill, if you want to just we're proud of him. He has been involved in this since the 80s, and he's a consultant in the PV industry for a variety of topics, and he's written technical manuals for the industry that are widely used throughout the country. And it's important to note that he's on the code meeting panel, number 4 for the National Electrical Code. Bill, you want to say anything as an intro?
Well, just happy to be here and talking about this subject. A lot of interest in this particular subject as it's one of the bigger changes in the last few years in the code, and so there's definitely a lot of need for education, helping people understand what it means and how to comply. And since a lot of the U.S. is on the 2014 code, we definitely want to talk a little bit about that. And then look forward as the 2017 code begins to be applied throughout the United States.
Thanks, Bill. Now, we also have SnapNRack with us, Ezekiel Ferguson, and just before you jump in here, Ezekiel, you can see that I've emphasized a couple of words here because we just love this mission statement by SnapNRack, where they're way they really, their philosophy is about simplifying the process and focusing on customer satisfaction. That's great stuff. Ezekiel?
Yeah, good morning, everybody, if you're on the West Coast. And yeah, we at SnapNRack definitely have developed a simplified system. We started about 10 years ago or so in 2007, and since then in 2012 we got our first patents from the patent office, and then 2014 we became UL listed, and just recently last year in 2016 we reached a full 1 gigawatt of product deployed. So we are pretty excited for our products, and yeah, we definitely strive to lower the install cost and maximize the productivity for our customers. And we have, so here is just some quick snapshot of our systems. We've got a Series 100 roof mount system. We've got a Series 200 ground mount system. The ground mount system is based on a 1.5-inch galvanized pipe structure. One of the things that sets us apart from other racking systems in the industry is our wire management solutions, and that is, one thing we'll be talking about today for sure is the MLPE attachment kit and how that is UL 2703 listed with the Jinlong rapid shutdown device. And then we've got a array skirt that just came out last year. It's a great aesthetic device for your array, and we are compatible with most all standard modules and MLPEs in the industry.
It really is a nice look on the roof with these new kind of, what do you call the piece that goes across the front there, Ezekiel?
That's an array skirt, yeah.
Yeah, it looks sweet on that roof, I gotta say.
Yeah.
Regarding the inverter itself for Jinlong Solis, I just want to go through a couple of things here. As I say, we're going to focus on rapid shutdown, but this is but we're going to be connecting the rapid shutdown either directly at the inverter or near the point of connection. And our inverter has some unique features. One of them is the multiple MPPTs. We have 3 and as many as 4 MPPTs, and it's quite fast, about a 3-second response time. And as I was showing this inverter here at the NABCEP conference, it was impressive to guys how easy it is to pick up, and it's just recently won an award for power for the unit volume for our 10K product. And indeed, it's pretty easy to pick. It's pretty easy to pick up. It's compact, and Jinlong has made a serious effort in trying to keep the unit compact and lightweight. It's a transformerless inverter, and it can be operated at 240 or 208 to 97.5% CEC efficient, and that ultra low startup voltage is 120 volts. And you see that our operating range for the MPPT voltage goes all the way to 100. So, that dude is going to wake up early in the morning, and it's going to stay out late till the string voltage drops below 100. So you're going to squeeze out as much as you can out of that sunlight. We have RS-485 Modbus communication protocol in these inverters, and we have our own Wi-Fi interface. And that's a nice way to get information off of each MPPT. But, should you want to bring in some weather data or maybe data from a smart breaker box or something like that, we are compatible with third-party communication systems. We've integrated the arc fault circuit interrupt. We actually built this board. Jinlong Solis is proud to say that we do not use contract manufacturers. We manufacture all of our own materials, test them, and package them for our worldwide presence. And AFCI, of course, was brought into the code in 2011. And it's also important to note that these inverters are Rule 21 compliant, and we have some really cool accessories to show you for them, and they come with this 10-year standard warranty that's extendable. The interesting product that we brought out and showed the NABCEP guys here at the CE conference here in Dallas was the 6 to 10K product, as well as our 3-phase product. this is our 4th generation product, and we made every effort really to try to ensure the package is tight and lightweight. I like to talk to our supply chain folks and talk to them about how you normally will be able to fit 6 inverters on a pallet. We've had some success over the past year and a half in introducing our 2.5 to 5K products, and you could fit 6 of those on the pallet. Well, indeed, with these new 10K, 6 to 10K products, we can also fit 6 on the pallet. The product is slightly deeper. It's got a deeper heat sink on it, but it's the same width and even a couple inches shorter. So you can fit the same number of inverters on the pallet, and the pallet weight was only going to increase by about 30 pounds, even though you've got twice the power on the pallet. You can see there in that chart that our 5K inverter weighed 39 pounds, and our 10K is only 44, so only 5 pounds of difference. And there, you'll also notice a couple of other things as you're touching the inverter. You'll see it's kind of a powder-coated aluminum enclosure. This is a NEMA 4X enclosure. You'll note in that photograph there that you see kind of the inverter on the top and then a wire box below. And this makes it slightly different than our other inverters that we have distributed in, for example, UK or Australia, where we don't require the wire box, where they can just plug the strings directly into MC4 connections right on the bottom of the inverter. Any of the guys that have been installing our 2.5 to 5K stuff will find the LCD screen and interface almost identical. It's got the same 4 buttons, the DC power light, the green operation light, and the yellow alarm light and the menu itself will be very familiar to all those guys who have been using our inverters since 2015. That's it for the inverters. But I want to talk a couple of minutes about the accessories, which includes our rapid shutdown device, and that's what we're going to focus on quite a bit here. But just as an aside, we, in addition to those inverters, we also provide some monitoring accessories. We have a Wi-Fi stick, which is really kind of nice. You just 1-minute install, and it retains the NEMA 4X rating on it, and a Wi-Fi box if you wanted a hardwire, for example, or you needed a little bit more broadcasting range. You can then, I just walked a guy through it just the other day on the phone, and it only took about 10 minutes to link the Wi-Fi stick to his local router, and then another 10 minutes to register on site. So it's pretty easy and a low-cost way to get information off of each MPPT and then feed it right to your phone if you'd like, using a web app. So, yeah, why rapid shutdown? These are difficult photos for me to look at. I've been in the industry for longer than 25 years now, and it just pains me to see some of this stuff. But, as good as some installers are, it's difficult sometimes to predict what kind of animals will crawl under there or some sort of accident, a tree falls. We had a huge windstorm in Michigan recently and took a lot of trees down, and that can fall in your array and cause faults that might light up some of the equipment. So environmental pressures beyond what was expected. I remember installing a system in Los Angeles, and we designed to 90 miles an hour winds there, but the Santa Ana winds came in at 111 miles an hour on that roof, and there were some parapet walls there that really got some turbulent winds in the corner and lifted part of the array, and we had to put that back. So things happen, no doubt about it, but installers have had to up their game a little bit in the past, especially since we've gone to high voltage systems. And so now we see that ground fault and arc fault is in our code. And so these types of problems can happen due to ground faults, and most inverters are protected for ground faults and or an arc fault and a series arc. And we'll be talking a little bit about that. That's what the rapid shutdown is about. And we'll talk a little bit about troubleshooting this sort of thing. But again, we don't want any of this to happen to you guys, and so that's why the fire departments in the U.S. have insisted that we start going towards string level shutdown and then in 2019 module level shutdown. And I've abbreviated the 2014 690.12 here a little bit, but I was, when I was in the PV Industry Forum looking at the code for 2014, Matt Pace from the San Jose Fire Department was advocating for the fire departments for changes here in the code, and indeed 690.12 was published in 2014 for PV systems installed on or in buildings, and they shall include a rapid shutdown function. And this, at the time, for 2012, it was 10 feet from the PV array. It had to drop the control conductors to less than 30 volts in less than 10 seconds. And also importantly, it also really emphasized the point that these initiation methods need to be labeled properly. And so that's important. Think about your fireman who's coming up to a home or a building that may be smoking or something like that, and he knows or has been informed there's PV on the roof. You know, when that first responder arrives, you want to have some clarity and some you want to pretend that you're that guy, and where would you be looking for that signage to shut down that array? So you want clear signage and labeling, and you want it to be located in the right place. And well, the PV industry responded when we were called to develop rapid shutdown. And, Fronius and Selectria and Midnight Solar, I just saw them here in Dallas, came up with devices, and they were able to build these devices out of UL-listed and UL-recognized components that were identified for, operating in these environments, proper voltage, that sort of thing. And we saw some really cool and different solutions to this for this requirement. Now, Jinlong, Solis, we also saw the need, and we developed something similar to what you see on the left-hand side there, the ABB box, and that requires, fairly vertical or maybe outside the array kind of mount, and you'd see that up on your roof. And so, well, we got a little bit of advice, actually, from the industry. We wanted to hear more about what would be even a better or easier installation. And we heard that maybe making that small enough to fit underneath the modules, that would be a good idea, and keep it cooler, and you wouldn't have that extra box up on the roof that might affect the aesthetics or, at the very least, be exposed to direct UV. And it was also important to note that the NEC allows for an AC control circuit conductors. It's important to call these the correct way. Can be run in the same conduit as PV source or PV output circuit wiring, and that's important when we're talking about reducing cost, and we'll get into that a little bit more. And then, of course, eliminating connectors and increasing the length of the wires on the inverter side really helped and ease wiring because, of course, we discovered that these rapid shutdown devices, now that we've created this what looks almost like a microinverter kind of package, will be associated with some sort of weather-tight junction box up on the roof where you're going to be making your wire drop down to the inverter from. So, indeed, we won't typically wire directly from the inverter side of this device directly down to the inverter. We'll almost always use a J-box to make that transition from wires in free air to wires in conduit. And so that's what we did. Jinlong came up with a rapid shutdown device. It kind of looks like a microinverter shape or optimizer shape, and it's a 600 volt device. We are working on a 1000 volt device or 1500 volt device for our commercial systems, but it's fully NEMA 4X. It has a little LED, a green LED on it to indicate that you have connected AC power to it. Now, this device is interesting in that it is listed to the UL 1744 standard, and it's labeled as PV rapid shutdown equipment. You'll see right on the device that this device is to be used for rapid shutdown of PV systems. And so consequently, with this kind of listing and labeling on the product for its specific purpose, you can use this in other systems. You can use it in SMA or Fronius systems, whatever you'd like. There's an indicator light on the front. You can kind of see it there right on the bottom there. It's a green LED, and what it'll do is it'll light up when you have applied AC power to the device. And AC power is required here because really this device is quite simple. It just has 4 contactors in it, in the positive and negative DC lines. And when what's going on is that these you attach to the string side of the device, and it's going to go through some normally open contactors. And what the AC power control circuit does, about 0.1 amp or so, it keeps those contactors closed. And so now, basically, the Solis RSD is just sort of a pass-through device. Now, what happens when the utility man pulls the meter, or the point of connection breaker is thrown, or the AC disconnect is moved to the off position, then that immediately cuts AC power to the inverter, and that will open up those contactors, and the array is immediately shut down. Now, there's other kinds of ways you can do this, little transformer run DC up there, that sort of stuff. But really, what Jinlong Solis thought when we designed this product is we really want to be able to simplify the rapid shutdown initiation process for the first responders. And so we thought that an AC power device where if they could just cut AC power to the building, which is a very common strategy for firefighters, would initiate rapid shutdown and make the array safe to work around. So at this point, I'd like to turn it over to Bill Brooks and to continue the conversation about the 2014 and why this was brought forward and what's going on in the future, and how can we all get in compliance and make sure our systems are safe for all our customers. Bill?
All right. Well, thanks, Terrence. That was a great overview, and I think we'll set up a lot of things that we're going to chat about here. Just to give some people some background on rapid shutdown in general, the terminology may not be the most accurate, and some folks, I'm sure, don't like it very much as far as the terminology, but this has come along, been coming down the road quite a long time, with working with the fire service over the years, and dating back about 10 years ago, fire departments started really understanding that solar was actually out there, even though it had been out there for some time. The fire service really hadn't really picked up much on that, and so as the fire service began to understand that PV systems were around, they made a very simple request, which was just give us a rooftop disconnect. We'll throw that disconnect. Everything will be fine, and we'll go about our business. And unfortunately, we had to tell them that throwing disconnects on rooftops was really, in general, very unlikely to do anything as far as improving safety. And so that was counterintuitive to them, and they said, well, why not, and why shouldn't it? And so we had to go through long explanations of how PV works, anytime the sun shines, and all those kinds of things. And so there was lots of discussion. In fact, there were whole states that adopted requirements for rooftop disconnects, and that was creating problems, and we had to roll a lot of those things back. And so ultimately we said, hey, listen, rooftop disconnects are not the answer, but we need to kind of improve things. We need to provide for something that actually does what you want it to do, so you don't have a false sense of security, you don't get firefighters hurt. And so rapid shutdown, long story short, it was originally called emergency shutdown, and said, oh, we can't use those terminologies because that has legal ramifications, so that's how we ended up with rapid shutdown. And we ended up with 10 seconds initially as our shutdown time frame, and we've extended that to 30 seconds, both in the 2014 code and the 2017 code. The way we increased it to 30 seconds in the 2014 code was through the vehicle of what's called a temporary interim amendment, which is basically an amendment to an existing code that goes into effect and until the subsequent version of that code is adopted. So until places have the 2017 code adopted, the 2014 code is intended to use that 30 seconds as the shutdown time period. The statistics numbers that you see on the screen here are just to help people understand that there's been an enormous number of changes in the 2017 code. most folks, except for those in Massachusetts, have probably not even cracked the book yet because it's not being adopted in their areas. And so just so they know, so you know, there's tremendous number of changes, lots of revisions, lots of paring things down and moving things to other parts of the code. Now, rapid shutdown, which we're talking about today, is a very key exception to that reduction process. And rapid shutdown was increased from about 133 words up to 1,100 words, and that was really due to the fact that the 2014 code was intended to be fairly basic, not a lot of specifics in it because we didn't want to constrain the process as people were learning and figuring out how to do it, as manufacturers were building products and things like that, and installers were trying to figure out how to comply, and local jurisdictions were trying to figure out what it all meant. But it became pretty clear pretty quickly that there was lots of variations in compliance and in methods, and so there needed to be more definitions, more specific. So that's why it increased quite a bit. And as you can see, there's a lot of things that got moved to other articles of the code that are no longer in Article 690, like energy storage systems. That's a really key point, and standalone systems, that the battery portion of a system, of a PV system, historically has been considered part of the PV system, is no longer considered part of the PV system. And that's really important in the 2017 code because it means that the solar installer is not required to do any shutdown of conductors related to the energy storage system. Whereas in the 2014 code, the existing code that most people are working under, with rapid shutdown, if you did have an energy storage system, you would be required to provide some shutdown capabilities, and we'll talk about that in a minute. So let's go on to the next slide. So the next slide is getting into the actual language in the 2017 code. And right up front, we wanted to make it very clear what we were not referring to when we said rapid shutdown on buildings. Some jurisdictions around the country have tried to categorize equipment enclosures that are used to enclose inverters and switchgear and things like that for a large-scale ground-mounted PV array to classify them as buildings. And if a jurisdiction were to call those buildings, that's their prerogative, but we wanted to make it upfront clear that from a National Electrical Code point of view and rapid shutdown point of view, those are absolutely not buildings for whatever reason that the local jurisdiction may call them a building. So that's the reason that exception is right up front, because it would be absolutely silly to require rapid shutdown in equipment enclosures and ground-mounted systems. Let's go on to the next. Okay, well, this is just a picture of what a roof might look like, and Terrence had a pretty picture as well. And these are not good situations at all, and we don't put them out there to glorify fires or anything like that. These are terrible things that can happen. Fortunately, we can say my understanding from all the fire work that I've done is that we've had no injuries, certainly no fatalities related to fires related to PV systems. There has been some damage of buildings and equipment. Let's go on to the next slide. But if those things are happening, we want our fire service responders to be aggressive in their attacks so that they will do what they normally do in saving lives and saving buildings. And so rapid shutdown is really all part about trying to reduce hazards in the array for first responders that are putting their lives on the line to save us and save our property. And for several decades, I've been in this for 30 years. For several decades, we basically put firefighters off and said, and other responders, and said, listen, there's nothing we can do about it. PV makes voltage every time the sun shines. There's really nothing we can do about that. And that worked for about 25 years. And so now we're in a situation where that discussion because of the advent of other products and new technologies, those discussions and arguments are really getting very thin. So here we go. Looking at the differences between the 2014 code and the 2017 code, we saw a very brief description of the 2014 code, and in the 2017 code, as we said, greatly increased the detail in the rapid shutdown, including what it applies to as far as the location of rapid shutdown, signage required, and all this kind of stuff. And then we defined an array zone. In the 2014 code, basically it says once you're 10 feet away from the array, you have to shut down all your conductors to 30 volts. But that does allow a fair amount of flexibility, and that was intended to allow flexibility. But when we looked at the 2017 code, there were a lot of folks that said, well, let's make that a lot more clearly defined. Let's talk about the distance from the modules. And so within 1 foot of the modules becomes the array zone, the array boundary. And we can put equipment in and along that array boundary, and it becomes part of the PV array. For instance, we could install an inverter within 1 foot of the modules, and then that extends the array around that piece of equipment. We could also have conduit in that 1 foot area, and that becomes part of the array. There are 3 options for reducing shock hazard within the array boundary. So this is really the huge difference, and certainly where the vast majority of the controversy lies in the 2017 code, is that not only was there a lot more definition of details of how to do rapid shutdown, but there was also a requirement to reduce hazard within the solar array. And so that is a dramatic change from previous requirements in 2014 code. And because of those dramatic changes, that particular set of requirements was delayed. It's called deferred or delayed enforcement until January 1, 2019. So there is no requirement to do this at the moment, but certainly there's also no restriction. People can certainly come in compliance with these things today if they so choose. So starting January 1, 2019, you have 3 options that you could meet the requirements for reducing hazard within the array. The first would be to have a listed rapid shutdown PV array. That is new terminology. It's terminology that I basically invented a few years ago with the idea of providing some perspective on what we might do that would be something that we wouldn't have to define all the bits and pieces of how you would do it in the code, but it would actually be part of a standard that would be a reduced hazard array standard. That standard is yet to be developed. There's some research going on right now related to that standard, but there's nothing on paper yet, and there are no CRDs from UL about that as it stands today. So item number one, it's impossible to comply today for, and we're hoping that by 2019 we'll have the standard ready, but we'll see. Second one is to curtail the voltage of the conductors within the array zone to 80 volts. The 80 volt number might seem familiar to some because it's the same number we use for arc fault detection. And in fact, in a lot of ways, we use the 80 volts for some of the very same reasons we chose 80 volts for arc fault detection. It doesn't necessarily have a lot to do with, it's certainly not considered a zero hazard shock environment, 80 volts. 30 volts DC is really the dividing line in standards for that. Nor is 80 volts a safe voltage for arc faults either. However, in both cases, 80 volts is dramatically less of a hazard than the 600 or 1,000 volts that we see in typical systems from both a shock and arcing hazard point of view. The 80 volts also relates to standard typical modules that are on the market today. Certainly all 72 cell modules fit within 80 volts by quite a bit. And there are some modules like SunPower makes some 96-cell modules that would also fit under that 80-volt number. That being said, there are some modules that are above 80 volts, and so if someone were trying to use a product that would shut down to individual modules, then products that were over 80 volts would not be able to comply to that with this particular requirement. There are also some other products that are not module level shutdown products that comply with the 80 volts, and one example would be 10K solar. Now, this is not a 10K solar webinar, so we're not going to go into a lot of detail about that product, but it's basically a low voltage array with microinverters, and so that's another way to do it as well. Then lastly, the third option would be to have an array that had no exposed metal or conductors in the PV array, and then the array was more than 8 feet from grounded metal, like vent pipes that might be metal, and flue stacks, things like that. It would have to be more than 8 feet from those grounded metals. And that's basically saying that even if you did come in contact with conductors that were live in a PV array somehow, by putting an axe through it or something like that, you're not going to have a return path through grounded metal, because grounded metal certainly is the biggest reason people get shocked on rooftops, is they're touching a live conductor and grounded metal at the same time. Very difficult to interject yourself within the plus and minus of a PV system unless you're inside of a combiner box or something like that. Then lastly, the 2014 code required that all equipment be listed and identified, and Terrence explained that quite nicely in that the products had to be listed to the proper UL standards and for outdoor use, temperature, current, voltage, all that kind of stuff. But we were very careful not to require them to be listed for rapid shutdown. In the 2017 code, we increased that requirement and made it a requirement that equipment had to be listed for rapid shutdown. And that is definitely a change. And so as companies go forward, then they'll have to get their products certified for rapid shutdown. And there are quite a few, including Jinlong's product, that are available that are listed for rapid shutdown today. And that's equipment. So it's equipment listed for rapid shutdown rather than the array listed for rapid shutdown. This is a diagram of what the array boundary looks like. That pink area is the area of that extends 1 foot beyond the modules in all directions in a two-dimensional plane is the best way to see that. But it doesn't proceed into the building. That's probably the best way to think about it. If you wanted to think of it in three dimensions, it would include all the dimensions except for into the building, because we want to treat conductors inside the building very differently. So any conductors that are outside this little pink zone would then have to be shut down to 30 volts in 30 seconds. And you see some arrays at the top that are disaggregated from the arrays at the bottom. And so in this particular case, you would have to shut down the conductors related to those areas for compliance with 2017 code up to January 1, 2019. Now, you'll also see on the left-hand side there, there is a DC combiner box shown, and that DC combiner box, if it were within 1 foot of the array, then that 1 foot boundary would extend around that box as well. And that's just to accommodate the ability to mount equipment associated with the rapid shutdown. Often we can't fit it underneath the modules because the modules are so close to the roof for other reasons. So there you see what the array boundary looks like. Let's go on to the next slide. The next slide is another picture of what an array looks like when it might have been damaged, and so we'll go on to the next slide after that. No reason to stay there, but part of this is that, if the fire department has to get in close contact with that array, that array obviously is heavily damaged. It'd be nice to know that there's very little, if any, voltage left there. especially if we had to rescue an injured solar worker, for instance, that maybe was doing some work on the array and got injured, and fire department had to be called, and now they got to go in there and rescue the person, save their life, and so we want to have those options available to us. So we'll go on to the, EVA is very flammable. There's a lot of flammable parts in modules, and certainly the EVA inside is flammable. Next thing we're going to talk about is rapid shutdown initiation devices. So the code talks about 3 different ways that we can actually initiate the rapid shutdown process. The first 2 are really specifically for products that don't have backup power. So if we don't have backup power, if we're just a grid intertied system, which most of the products that we've been talking about today are, then certainly just shutting off the AC side can be used to initiate and shut down the DC side of the PV system. And that's really what we're after here. And so as the service disconnecting means, if we're on the load side of the service disconnect, our PV inverter's on the load side, then just opening the service disconnect, maybe do everything that that's possibly can be done to shut that system down. And then also, if we're making a connection on the supply side of the service disconnecting means, the PV system disconnecting means might also be used as the rapid shutdown initiation device. And certainly, even if we're on the load side, we could also use the PV system disconnecting means as the initiation device, because we don't necessarily want to require that the service disconnecting means be used to shut down the PV array in a rapid shutdown situation. Here's an example why. I would say in residential, service disconnecting means would be fine, and it would work great. In a very, very large service, even if we're on the load side of that service disconnecting means, we may want to have the PV system disconnecting means used for initiation because, and the reason being that some fire departments may want to keep the service disconnect on for the purpose of providing power to ventilation. So we have mechanical ventilation in the building. They may say, hey, keep that stuff on, keep it going, don't turn it off. Don't turn off the service disconnecting means, but okay, we can use this other switch, the PV system disconnecting means, to turn the PV system off or make it more safe. And then lastly is the option to use a readily accessible switch that plainly indicates whether it's in the on or off position. In this particular case, that could be a push button, it could be a knife blade switch, it could be any one of several products. And if you look at products like SMA's product and Midnight Solar's product, they will have a separate initiation device, and that initiation device is simply just a relay that opens a circuit and shuts down whatever is connected to that relay. And again, that's being used because there are typically backup systems being employed in the system, and those backup systems are intended to operate anytime the power goes out, and so you don't want to use a loss of AC power for backup power systems because that would certainly make them useless. We don't want to do that. So let's go on to the next slide. Next slide is an example of a system that, in this particular case, if you read the fine print, it would be indicative of a microinverter system where you might have microinverters, a couple circuits of microinverters up on the rooftop, and if you shut off the main service disconnect or the PV system disconnect, which would be a circuit breaker or something like that, then all the AC side goes down, and you're left with just simply the DC voltage of the individual modules, which we're showing in this particular example as yellow, and the AC as green. Now, it could be that this particular diagram could also be an example where you had an inverter down at ground level next to the meter panel down there you see at the ground level. And then up on the roof, you had some other type of a device, but maybe that's just a junction box. And then you could have individual DC optimizers or converters in the array, and the individual optimizers or converters could shut down the output of the modules and the series stringing of the modules and leave you with essentially a DC converter circuit that has no voltage on it or very little voltage on it, and the modules again would be at a 80 volt condition or less, probably more like 50 volts for a 72 cell module. So that's an example, and if we see red, as we'll see in some subsequent drawings, then we'll also have higher voltages available. But this is showing everything being shut down within the array to 80 volts, and then wires leaving the array shut down to 30 volts or less. Okay, let's go on to the next slide. There is an informational note trying to help people with the understanding of why that third option is there for the initiation device, and that's for having optional standby systems, backup systems that remain energized upon loss of utility voltage, because a lot of folks may say, why in the world did you even have that there? So we figured it would be helpful to give people a little heads up on why. The next slide, we're going to talk a little bit about the readily accessible switch. The fact is that in the rapid shutdown switch is required to be on the external, on the exterior of a building for 1 and 2 family dwellings. So regardless of whether it's the service disconnect, a PV system disconnect, or a separate switch, one of those three would have to be, whatever is being used as a rapid shutdown switch would have to be on the exterior of the building. In a commercial construction, it would not be required to be on the exterior. This particular example is showing a 2014 style application that could be also done in 2017, but we'll talk about it in the 2014 code. And this is showing a battery backup system. And it's got an optional standby breaker panel. It's got a DC input to the inverter. It's got the battery input, and it's got an AC tie to the grid. Very common battery style system, even though battery systems are not extremely common except in Hawaii right now. And so the code in the 2014 code requires all those circuits 10 feet from the array, which is what you see up on the roof, and that might be a few feet, maybe 5 feet from the array. You see the control box, and then within 5 feet lengths of conductors inside the building. So you see small red streaks inside the building around the inverter. Might be a small circuit to the battery. We don't want to have to put a control circuit on the battery, so to keep the battery close to the inverter. We also we may have to have a control circuit on the input of the inverter. And Terrence showed Midnight Solar's products on that subject that could be used for the input and output to the inverter. And then there's a push button or some type of a device on the wall. Midnight Solar has their little birdhouse product, and you operate that button or switch, and that activates the rooftop switch, the input voltage switch, the output voltage switch, and all those things simultaneously, and it takes that particular system into a safe state for the 2014 code. Now, in the 2017 code, the code would only require us to control that circuit that comes down off of the roof and goes to the inverter. That's the only circuit that would be required to be controlled. And the control box would have to be within 1 foot of the array. So we'd have to move that thing over closer to the array to be within 1 foot of the array. And up until 2019, we could leave the rest of the array at 600 volts on a residence. And that's why we show that red section above 80 volts. Now, that doesn't mean that we can't do all the other controls that you see there. And of course, Midnight Solar has listed products that can do all that. And so it's certainly possible to comply with the 2014 code and with the 2017 code, and then do more than the 2017 code requires. Let's go on to the next slide. Okay, so one of the things that does happen from time to time is we'll have multiple PV systems on a single service. And so if there are multiple locations where those PV systems come in, then that creates some difficulties. If they all come into one location, then the code would allow us to group those disconnects in one location. And we could have, say, a group of circuit breakers going to separate PV systems, And if they're all in the same enclosure or in a group of enclosures that are right next to one another, then the code would allow us up to 6 of those devices for a rapid shutdown initiation device. If they're in different locations, say they're coming into different subpanels in the building, then that's going to create some issues from the standpoint of the ability to operate that all from one location. So in this case, the code wants us to operate all the rapid shutdown switches for a service in one location, and that may cause us to go into a system that, in fact, the easiest way to do that, in my mind, would be to use the main service disconnecting means as the shutdown device. And again, if we don't have backup loads and battery systems and things like that, operating the main service disconnect is going to shut down all the PV systems at the site with one motion, and we'd label that main service disconnect as the rapid shutdown switch, and we are done. So that's a very simple way to do it. There's also a case in some very large buildings where we'll have multiple services on a single building. There's nothing in the rules against that. It's not very common, but it does happen. And in that particular case, the rapid shutdown system does not have to control the PV systems on other services to the building. Only the service that it's connected to does the rapid shutdown switch have to address. And as we'll see in the next couple of slides, we're going to talk about the signage that has to go on that switch and where that signage has to be. So let's go ahead and go to the next slide, in which we're going to talk about equipment. Next slide basically is to make it very clear that equipment that's performing rapid shutdown functions is going to have to be listed for rapid shutdown, with a very key exception that we kind of showed in red here, which to make it very clear that things like listed circuit breakers, disconnect switches, and control switches that might be separate switches, that similar to what, say, a button or a knife blade switch we'd use as an initiation device, or a main service disconnect. We're not expecting a main service disconnect to be listed for rapid shutdown. It's just an on-off device that does everything that we require of it in the system, and we don't want a local jurisdiction saying, oh, I want to see a listing on that thing for rapid shutdown. It's absolutely unnecessary, and we made it very, very clear that it's unnecessary. The informational note is just to say that some inverters, particularly older ones, older single-phase inverters, might have up to a 5-minute time after you shut them down that for the voltage to bleed off, because the listing requirements in UL 1741 only require that the inverter de-energize the inputs in 5 minutes. So the bleed resistors that are in those systems are designed for a fairly slow shutdown, and that would be unacceptable in a rapid shutdown situation. And so in order to get in that voltage down below 30 volts in 30 seconds, it often takes inverters with large capacitance to have extra bleed resistors brought into the circuit. And so those extra bleed resistors may be in the rooftop switch. And the good news to the installer is you don't have to worry about that, because that's all part of the rapid shutdown listing. So particularly products that have been listed for rapid shutdown, inverters and their control boxes and things like that, as with the Jinlong products, they have been listed together, have been tested together, and meet the requirements when installed together. And we as installers in the field don't have to go find resistors and all that kind of crazy stuff. That's all covered in the listing process. Let's go on to the next slide. Next couple of slides, we're going to talk about the signage. And quite frankly, the signage portion of the rapid shutdown requirements are every bit as important as the actual equipment itself, because this is all about communicating to emergency responders the correct information so that they can go about their job in a knowledgeable way and attack the fire or save the person in distress with confidence in knowing what the hazards are that they're being exposed to. since I'm not a firefighter, I can't speak on behalf of the fire service directly. All I can do is share my experiences in seeing how fire service works and how they do their job. And firefighters are not scared of anything except the unknown. And so, you know, a lot of times they may go into a situation that could be very hazardous to them. If they knew about the hazards, it wouldn't necessarily change their operations much, but they would just be more prepared for whatever they have to face there. So in this particular case, this is the rapid shutdown sign in the 2017 code for when we reduce the hazard within the array. Now, this is only required after January 1, 2019. However, if we were to comply with the requirement today, which is possible, either with, say, N-phase products for microinverters or Solar Edge products for DC converter products, things like that, if we were to use things like that, then it would be appropriate to apply this sign. And at the top is actually the wording that's in the 2014 code, which is solar PV system equipped with rapid shutdown. So that terminology is basically in the 2014 code. And then we have extra information here and a cute little house. It's not really a house, just a building that says, turn the rapid shutdown switch to the off position to shut down the PV system and reduce shock hazard in the array. Let's go on to the next slide. We'll see what things look like when we're not shutting down the conductors or reducing the hazard within the array. So if we're not going to reduce the hazard within the array, then we turn this sign red to make it a warning or a danger sign. Same wording at the top. And then it says, again, turn the rapid shutdown switch to the off position to shut down conductors outside the array. So the conductors leaving the array are shut down. But then we're reminding everyone that conductors within the array remain energized in sunlight. I would highly recommend that even if you're using the 2014 code and you're not using N-phase or Solar Edge, that you apply this sign. So if you're using Jinlong product today and you're looking for a sign, even though the 2014 code, let's say you're under the 2014 code, and the 2014 code only requires you to put the terminology at the top of that sign, I would put the whole sign in. And here's the reason. We want firefighters to get the right information and as accurate as information as possible right away. And if you do give them the right information, they're far more likely to fight your fire aggressively with that knowledge in hand. Okay? And so that's why it's useful to do. And so there are several companies already that manufacture this sign. Hellerman Titan is one of them. And I think PV Signs is another one. So you can go online, you can get these signs, and you can make them yourself. There's nothing that says this does not have to be manufactured by somebody. Certainly, any sign we install in the field, according to the National Electrical Code, has to be able to withstand the environment that we put it in. So if this is an outdoor location, then, which it often would be in a house, we'd like to keep that in the shade as much as possible. And also would have to be pretty durable, probably a plastic engraved sign, something like that. Let's look at the next slide. Now, this raises some interesting issues as we move forward, and that is, what if you had a PV system that complied with different versions of the National Electrical Code? Let's just say you're in Massachusetts, and 2 years ago you installed a system according to the 2014 NEC, and that's over on the left-hand side of the roof, and then, or the west side of the roof with our little north arrow, and then you're contracted to double the size of the array and put in a new array, and this new array has to comply with the new requirements on the 2017 code, and therefore you're shutting the modules down, shutting down to, let's say, the module level. You chose to do that. Well, in this particular case, now you have two different types of shutdown on the roof, and the code basically says, in that case, then you need to show a plan view of the roof with a dotted line around sections of the roof that remain energized when the rapid shutdown is in the off position. That being said, there are jurisdictions out there that have decided that if a roof already has a PV system, for simplicity's sake, that they may not require rapid shutdown to be employed on the new section of the roof or on the new installation, just to keep the confusion down, so that a firefighter gets up on the roof and they say, well, I forgot the map, I can't remember which end of the roof is unsafe, and so they're probably going to have to operate as if all of it's unsafe anyway. So going to the extra cost of adding the rapid shutdown requirements may not be all that beneficial. So that's a jurisdiction by jurisdiction decision. The 2017 code requires it to be done this way. All right, let's look at the next slide. The next slide is talking about the rapid shutdown switch and the information that has to be available on the rapid shutdown switch. All right. Now, generally, we're going to have white lettering on a red background, but this slide got changed a little bit, but that's fine. The main point here is that label would have to be within 1 meter of the switch, whether it's the main service disconnect, PV system disconnect, or some other device. And we also could have multiple rapid shutdown switches. So the code says, hey, you can have multiple shutdown switches on a building. Let's say you had one outside required by the code. You got to have at least one outside for 1 and 2 family dwellings. But let's say the main service disconnect does the exact same thing as the outside switch does, and it's in the basement. And let's say the firefighter runs down to the basement first, never saw the one on the outside of the house, and they go ahead and pull that switch. Well, they should know that they've done the exact same thing. So there's nothing wrong with having several locations where the rapid shutdown switch, if it does exactly the same thing in multiple locations, you can have multiple places where it's identified. However, if you do not have the rapid shutdown switch at the main service disconnecting means, for instance, let's say you had it in the base, you have a main service in the disconnect in the basement, and the rapid shutdown switch is on the outside of the house because you have a backup power system, for instance, and you don't want the main breaker to be used as the rapid shutdown switch. In that particular case, then the code requires you to have a sign at the main service disconnect, which shows the location of the rapid shutdown switch. And so that's just to be clear that I got to the main service somehow faster than I got to the rapid shutdown switch, and for some reason it's not at that same location. I show that location at the main service disconnecting means. All right, let's go to the next slide. So 690.12b2 is the section of the code that deals with shutdown within the array. And as it stands right now, Jinlong's products are designed to comply with the requirements that are in place today in the 2014 code and will stay in place until January 1 of 2019. So for the next 2 years, the Jinlong product is certainly more than adequate, certified, listed to rapid shutdown, all that for the 2017 code and the 2014 code. But when we get down the road to actually requiring shutdown within the array, which is 690.12b2, then there are products out there today that actually can provide that compliance. And one way to augment a Jinlong system would be to install DC converters, or what they're called in the field as DC optimizers, that would shut off the individual modules. And that would certainly be one way to do it. Obviously, we can use microinverters inside the array, and we could do a built-in integrated system with no metal parts and no exposed wiring that's more than 8 feet from grounded metal. All right, let's look at the next slide and talk about standards for a second before I pass it back to Terrence and SnapNRack to talk about their products. And standard needs to be developed to certified equipment. There is a process that's been under development for some time. We're hoping to have the final version of that to the standards technical panel within the next week or two. And then that will get voted on over the course of the next month or so, and comments and all. Hopefully we'll get through that process by early summer, and then we'll have a standard on the market. Now, you say, well, okay, how are products like Jinlong's products being certified today, even though there's no standard officially processed? And the answer is there is a draft standard that UL has, a draft standard that Intertek has, and it's very close to what's going to be adopted by the Standards Technical Panel. And there is nothing preventing a listing agency from listing to a draft standard today, and that's why we have a couple dozen products that are available in the market. So then once that existing standard process is established for products to address conductors outside the array, then we also have to address the listed rapid shutdown PV array products, which is going to be the actual power producing system going to a lower hazard level for the 2019, for January 1, 2019 and beyond. That being said, even if that standard is not available by January 1, 2019, and we don't have any products for that, we still have the option of using products that meet the equipment standard that is being certified right now, and to control conductors coming out of the modules or out of an array, and shut the array down to 80 volts as an option. So those options do exist. So that's it for me, and I'm going to turn it back over to Terrence and take it away. All right, this looks like Jinlong's product. And
all right, thanks. Thanks, sir. Can you hear me now?
Yep.
Fantastic. I just thank you, Bill, for reviewing that comprehensively. I have a better understanding of what's coming up in the future. As Bill noted, we got this product listed that you see there pictured on the right. This is kind of how you would receive it. We took some advice from the industry, and this is what we have today. You can see on the string side, we've identified it as STR. We have MC4 connectors, and those MC4 connectors can tie directly to your PV strings. It should be noted, actually, that the positive connectors on the negative conductor, negative connectors on the positive conductor, just to note that. But we've labeled each wire to ensure installers can get the polarity correct. And polarity needs to be correct when you're wiring the rapid shutdown box in between your PV array and your inverter. On the inverter side, we've extended the wires a little bit, make it a little easier to run into a J box, and of course the whole box is quite thin, so you can mount it to the rail system using that you can see it's a non-anodized mounting plate, very similar to what you see on optimizers or microinverters. So we wanted to make something familiar to installers and something installers could use to get a good bond to the rail system. So again, in that photograph, you can see the MC4 connectors on one side and the whips on the other. So after just sort of a brief introduction of what we've done to try to improve not only compliance, ease of compliance, and ease of installation, well, we need a little help there, as I said, because those whips need to go somewhere. And so we've found a great solution with the SnapNRack equipment. And I'd like to turn it over to Ezekiel to go through, to take a look at this slide here and explain the differences between these two systems.
Yeah, thanks, Terrence. So what we're looking at here is a SnapNRack Series 100, which is a roof mount system, and the SnapNRack Series 200 ground mount system. And if we go down to the next slide. So here we have the SnapNRack wire management systems solutions. And so one of the first things you notice is the rail itself is designed with two channels, and these are great for managing the conductors coming out of either the modules themselves or rapid shutdown devices or MLPEs, or the the side channel there is excellent for managing the trunk cable coming from the N-phase microinverters. And you can manage that with the wire clip. It's the wire retention clip there, the little plastic one. And we also have 4 wire clamps that use a 1/2-inch bolt. In fact, all the parts in the SnapNRack, the wire management parts and the installation parts, the one tool system, it all uses a 1/2-inch socket to tighten all this stuff down. And we have our J-box, again, excellent for terminating all of your conductors and your AC control circuit cable from a rapid shutdown device and making that connection to your standard THHN, that transition there. And then on the very bottom right-hand side, we have the MLPE attachment kit. And we can go ahead and go to the next slide. So the MLPE attachment kit has been tested, third-party tested and evaluated, and has been listed under the 2703 listing for grounding compatibility with the SnapNRack system and the Jinlong, the Solis RSD equipment. And you can see here, so you can actually ground the thing. You can ground the Solis RSD with through the AC control cable, but the standard, the kind of standard practice that Jinlong recommends, and really the best way to do that, is grounding it through the back plate. And the simplest way to do that is to use a 2703 bonded equipment, listed equipment, and the SnapNRack MLPE attachment kit works great for that. You can see the image there. We've got the large fender washer that goes underneath the base plate to support the equipment, and then we have the wire retention clips that really manage those conductors well. One key thing to point out here is when you do install this, you want to make sure that the large fender washer goes underneath. And typically you see a washer and you see a bolt and you put the washer right underneath the bolt head, sort of a reflex, but in this case it's really there to support the equipment and make sure you get that good bonding connection. I'll go ahead and we can switch to the next slide. And I think that's you, Terrence.
Yeah, and so indeed, that washer image is important for the installers to understand and how we want to put together that MLPE kit so that we can get an excellent bond on the roof. Because indeed, as Ezekiel mentioned, we as a manufacturer have found that bonding on the roof there at that plate is really the best way to get an excellent grounding bond for the equipment. That equipment that you saw up on the roof there, both our 1-channel and our 2-channel products are that same size. So you'll notice in one product that you'll see the 2 channels and the other one just a single channel, but I'm showing just a single line drawing here of our 2-channel product where one channel is rated at 20 amps and the other at 10 amps. And so theoretically could double up a string per NEC without fusing on one of the channels, a 20-amp channel, and you could use a Shoals Y connector if you wanted to wire in free air, or you could even use another SnapNRack junction box to make that parallel connection between those 2 strings. If you are going to do this, if you are going to pair up 2 strings on the roof like that, well, you should probably pair up a couple of strings that are the exact same number of modules per string and probably have very close shading issues, if any. And that way you won't get a lot of imbalance between those 2 strings. So I think this is, for example, we have a 4 and a 5K residential inverter that can accept up to 18 amps on one input and 10 on the other, and so this particular configuration would work great with those. The key thing to note on this one here is the red arrow pointing to a circle that encompasses both the 240 rapid shutdown AC control circuit conductors as well as your PV output circuit conductors. And it's kind of important to understand how and why we can put both of these circuits in the same pipe. You will find that when you're up on the roof and you're connecting these rapid shutdown devices to your strings, that if you are going to be putting new MC4s on your circuit conductor, your PV source circuit conductors to attach to the PV side of the rapid shutdown device, we highly recommend that you use a proper MC4 crimper to ensure that those you get factory quality connections. We have found that potentially, if you're not using that MC4 crimper to make your MC4 connections, there's a possibility, or let's say a greater possibility, that you may find an arc fault or create an arc fault situation in those connectors. So we highly recommend. I know it's pricey, but we highly recommend that if you are going to be using the MC4 connector so much to be attaching to this rapid shutdown device, we highly recommend you use a proper tool there. Again, the electrical work box or those Y connectors from Shoals can be used to parallel a couple of wires. Indeed, the electrical work box, like the SnapNRack non-metallic work box, worked great there. So that's the DC side. On the AC side, we want to make sure that we have an NEC compliant connection to connect those PV strings to the inverter side of the RSD. They can route this AC control circuit cable from that roof-mounted electrical work box. You can also, and I'm showing here a Burndy lug, an insulated Burndy lug. If you had multiple RSDs, rapid shutdown devices on the roof, you could daisy chain that AC control circuit to feed each one of those rapid shutdown devices. And you might use, if you are going to continue in free air with that AC control circuit, you might consider something like a TC-ER type cable. This is a 240 circuit, L1, L2, and it's carrying about 0.1 amps. So you can use relatively small wire in that TC-ER cable to carry that AC control circuit to multiple RSDs. So grounding it, as Ezekiel covered, we have a number of ways you can do this. You could use a weave washer, but we of course recommend that SnapNRack MLPE kit, and that makes an excellent bond, and it's a great way, we think, the ideal way to attach the product to, not only attach the product because of that way the washer is positioned, but also to bond it effectively. Now, if you can also, if you're just using a standard mount to attach it to maybe some rebar or some unistrut or something on the roof that you put up there, there's a bonding lug there that you can attach to, and you can put your solid core number 6 and number 8 ground wire to that grounding clamp right on the RSD. So that's a second way that you can ground it. Now, you'll notice in our earliest versions of the rapid shutdown that we had a 3-wire cable for the AC control. We had a ground wire in there, and that was a third alternative way to ground this device on the roof. But you'll notice in the latest versions, which are called Sun V2, SUNV2, you'll notice that that TCER cable, that little 2-foot whip that comes out of the inverter side of the RSD, is just a 2-wire cable, L1, L2. And so that we're I guess, really let's say, focusing the installers to take a look at really using that grounding clamp on the RSD or using an MLPE kit from SnapNRack to bond the unit to the rails. And this is what it looks like on the roof. You can see that really cool wire management kit on the right-hand side there, managing the string 1, positive, negative, string 2, positive, negative, going to the string side or PV source circuit side of the rapid shutdown device. You can see how the rapid shutdown device has been bonded to the rail system using their MLPE kit. And then you can see that on the inverter side of the rapid shutdown device, those wires are being routed into the SnapNRack J-box. And you'll notice that string 1 goes in there, string 2 goes in there, the bare ground wire goes in there, and the AC control circuit conductors are routed into this one box. And then you've got a single conduit run down to the roof, down to the inverter. And we can do this following the guidance in 2014 under 300.3, AC1. We can, run these conductors as long as they're under 1,000 volts and we have the proper insulation ratings. Indeed, we can do this. And of course, your inspector might say, "Oh, hold on now, AC and DC in the same pipe is verboten in solar," and you'll point out to him that he's correct. As you always want to do with your inspectors. Indeed, under 690.31b, you are not allowed to run those inverter AC output circuits and your PV output circuits in the same pipe. So, indeed, you can agree with your inspector and yet respectively show him that under 300.3, we are allowed to run the AC control circuit conductors in the same pipe as our PV output conductor. So that's a very typical look on the roof, and of course that all fits under the modules real nicely, and then, as I say, a single pipe down to the inverter. On the AC side, there's a couple of ways you can go. Of course, you're going to route, if you look at that bottom photograph there, the AC control circuit conductors and your PV output circuit conductors coming from the rapid shutdown are going to be fed into, let's say, that left-hand side. And on the Solis inverters, you'll notice you can bring it in the bottom or in the back or in the side. And you're going to land your DC conductors at those multiple MPPT connections on the left-hand side there. You'll note that there's a blue box in there. That was a revenue grade metering system that we are just sort of fitting in the box during a trade show, so you can ignore that. But you'll note that there's a ground bar down at the bottom. That's where you would bring that bare copper wire down to. And you'll also note in that photograph on the bottom that we have added a couple of small rapid termination or cage terminal type terminals to the AC side of the Jinlong inverter. And this is a nice convenient spot to land those rapid shutdown conductors. If your inspector is a little concerned about energized conductors in parallel with these AC output terminals, then you can put a little 1 amp fuse in there, inline fuse in one of those conductors if you'd like. But I really like these rapid termination type terminals, these cage terminals. You stick your screwdriver in that hole right there or right there, and you lever up your screwdriver a little bit, and it opens up the door inside of that where you stick your wire in, and you stick your wire in and remove your screwdriver, and that door comes down kind of like a garage door or something down on your wire, and you can get a nice gas tight connection of your wires. I like them a lot because most terminations are pressure terminals where you're screwing it down. If you screw it too hard on a multi-strand wire, you're kind of spreading out that wire, maybe not getting an ideal connection. With these rapid termination terminals, you don't have to worry about vibration. They're really resistant to loosening up. You don't need to retorque these inverter connections, which a lot of inverter in the back of their manuals will note that you need to retorque these pressure terminal type terminations in their inverters, because over time with heat and cold, changing the temperature inside that box and maybe some vibration from machinery in the buildings or something like that, those terminations will loosen up, and it's part of your O&M as an installer to make sure that those pressure terminal type terminals are tightened up, every 6 months or a year or whatever. Whereas with these cage terminals, that's just not an issue. It provides a nice gas type connection that's not affected by vibration. Now, in the top photograph, you'll note that you see a cage terminal that's been kind of retrofitted to the inverter that includes your L1, L2 connection for your AC output, and we have a neutral there as well, and a ground, or PE as we like to call it at Solis. But then you terminate your wires down here. So these terminations can be used in this case, directly in parallel. And here we've got with the new 4G products, the 4th generation products, we've got a specific place for you to land your RSD. Now, of course, you could also pull your AC conductor through and pull it out on the AC side and land that at, for example, an e-stop switch. For example, you're in New York City where they actively prevent you from putting some sort of utility accessible AC disconnect switch out accessible to folks. And many installs where you have the inverter indoors. And so if you did want to specify a particular switch for rapid shutdown in this case, you might run that AC control circuit conductors outside of this wire box on the bottom of the Jinlong inverter and run it over to an e-stop or even its own breaker or switch specifically designed for initiating rapid shutdown. So it's not so hard to commission it, truthfully. As I say, it's a relatively easy device, but you have to ensure that if that green LED is illuminated on there and you've provided AC power to the device, you've got a pass-through device. So there's power on both sides of the unit. So PV guys know this well, and of course you have to act safely around if you are working in the sunshine to ensure that if you've provided AC power to this device, you're going to have hot conductors on the inverter side of the rapid shutdown. So you want to make sure that everything's, all your wire management components, all like that SnapNRack 4 conductor wire management device and all of your componentry, your mechanicals are all fixed properly. You're going to confirm the ground continuity and the polarity of those DC conductors, of course, during installation. And then to commission this dude, you're going to energize the inverter AC output terminals. And if you have connected your rapid shutdown L1, L2 to those terminals inside the inverter, in essence, you are also energizing the rapid shutdown device. If you have another switch or you have landed the AC control circuits at its own breaker, you would energize that circuit now as well. So as soon as you energize that rapid shutdown device, it acts as a pass-through, and you will see the red DC power light come on the inverter. Because remember, the Jinlong Solis inverters are DC powered, and of course, if the rapid shutdown device is not energized, then you're not going to see any power at the inverter. So to commission this device, you're going to power up the rapid shutdown device. You're going to confirm that the red power LED has come on the inverter, and you are going to then start to see the green LED blinking, indicating that the inverter is initializing and getting ready to start up, and after 300 seconds or 5 minutes, the inverter will come on. So that's the commissioning process. If you are troubleshooting this device, and Jinlong Solis is developing a troubleshooting presentation. We're actually thinking we could do something for the NAPSET program specifically, and when we get into that, we will talk about how we can use the multimeter, of course, to ensure that polarity is correct. But when you start seeing some alarm codes, just using the multimeter alone might not be enough to not only identify the problem, but ensure you know where it is. And so with your multimeter, of course, you can for sure check out unexpected DC voltage and ensure polarity is correct. But you'll see some alarm codes on our inverter that you may need other tools for. But I just wanted to, just as a brief kind of introduction to our overall troubleshooting presentations that we're developing, I wanted to go through a few common alarm codes. We don't have a lot of alarm codes with our product, but we have a few common ones. One of them is any fault, or the digital signal processor had a fault or something. In these cases, typically would indicate to the installer that we would replace the inverter. But if you had a under bus voltage or over bus voltage or over voltage DC, we can check this with the multimeter and make sure that our array voltages are within spec, under 600 volts, for example, or above 100. Now, The last two here, a grounding problem, a ground fault problem, or an arc fault shutdown, are two things, of course, in the inverter. If the inverter somehow sees 600 k ohms, or less on your PV output circuits, it's going to shut down the inverter. And this could be due to damaged PV modules or something like that, but frequently a grounding problem is skinned insulation that now has copper in contact with your conduit or other metal in the system. And so you can use a digital multimeter nicely to kind of check the voltage of that string and identify, is that 2-3 modules up or what. So finding ground fault problems with a multimeter is something a practiced and experienced PV installer can typically find. But finding arc faults, even the most experienced guys, it's sometimes a bit of an art and a lot of experience in trying to find some of these intermittent faults especially. And so if we do have an alarm like this on a Solis inverter, the inverter will shut down and you have to manually reset it. And well, if it's intermittent, you may be able to go up on that roof and use some sort of temperature indicator or like a FLIR infrared camera or something to even I think that those two devices are probably easiest to use when you're trying to find a hot J-box or unusually warm connector pair or something like that. I remember I noted about that MC4 connector. And so you also might see that using a string analyzer or even a megometer might be a good way to try to identify arc faults within your system. So if you see some of these error codes, it potentially could be related to the rapid shutdown device, but most often it's related to some fault within your DC PV home run or within the strings themselves. Some module got damaged. It was difficult to find the problem when you first installed. So that was our webinar for today. We want to wrap this up now and take some questions. Before we open it up to the crowd, though, I just wanted to put in a little plug here for our webinar series that we're doing at Jinlong. Next week, we're going to be talking about our 6 to 10K inverters, and then in April, we start out with a financing partnership with Hero Pace with Renovate America, and then on the 14th we're going to be talking with Trina and the Tigo Optimized Solutions, and we're going to have Trina and Tigo and Jinlong on the webinar as well. So we hope that you can join us for that. Bill, you also have some education resources available online. If you want to talk a minute about that.
Oh, basically some fairly dated stuff, but certainly good information, related to code stuff. Most of the stuff that I have available online nowadays is going to be found on in articles in Solar Pro magazine. So I've got articles in Solar Pro magazine that relate to this information, and of course the International Association of Electrical Engineers, which is IAEI, IAEI magazine. There's an article about the 2014 code, and so feel free to download. Those are all free resources, and that's probably the best way to get recent information.
Thanks, Bill. In addition, SnapNRack also has training and digital tools available online. Ezekiel?
Yeah, hello. Thanks, Terrence. We have a great online tool. You can go ahead and configure your array. It's got multiple modules, makes, and manufacturers. All the necessary built-in design parameters are just part of a drop-down menu, so you can go ahead and select that and just build your array. The best thing the great thing about it is it comes out with a bill of materials that's really specific to your job, and you can design up to really, really large, 500 kilowatt jobs if you want, but typically they're residential multiple roof systems. so we have the online resources. We have the applications engineering team will provide warehouse demonstrations and pilot installations, just to kind of get you rolling with the SnapNRack products. Thanks, Terrence.
Thank you, Ezekiel. And I'd just like to just generally thank our presenters today, Bill and Ezekiel. Thank you for talking with our attendees. You know, and that you can get to those guys on their websites. And I just wanted to show you a final picture of our factory. We across the street from this photograph, there's our wind factory. We do wind inverters and wind machines. But on this one here is where we do manufacture all of our PV equipment. And you can see a lot of PV on the roof there. And we do all of our manufacturing and the management of the company from this building. And so we are not a contract manufacturer. We do our own manufacturing and our own quality control systems. And so in conclusion, I'd just like to open it up to the group, and we can take questions either voice or by text or by chat line. And indeed, we will make this presentation available to you. We'll follow up with a note to all you attendees, and we will send out the presentation, and you can check it out. And please feel free to email us, to contact either Ezekiel or Bill or myself about questions that you might have on our equipment. And thank you so much for attending. We really appreciate it. And everybody, have a great day and stay safe. If you've got, I'm going to stay on the line here, and if you've got any other questions, we'll hang out for a few minutes. But Kathy, I think we're done. And thanks so much, everyone. Have a good day. Did you see that question there, Ezekiel? We're wondering if there's any discounts for joining. I can tell you that we have registered this course with NABCEP, so I can definitely tell you that we're offering a NABCEP CE points here. Thank you for attending, but I think Ezekiel will have to speak to any sort of discounts on equipment.
Yeah, I don't think there's going to be any discounts on the equipment themselves, but as you pointed out, there are NABCEP credits available for taking the course today.
Thank you. All right, we'll keep this open for another couple of minutes, and again, thanks everyone. Really appreciate you attending today. I know there's to be out there on the roof making some bucks, and you learned some hopefully some new things about not only rapid shutdown equipment, but also ways that you can use that equipment to stay in compliance, not only now but into the future. And I hope that some of the stuff that Bill brought forward on what's going to be happening with the code will help you prepare your businesses for staying in compliance and keeping not only your customers safe, but also those first responders who have to get up there and bravely fight any issues you might see up there on their roof. We see one question here, the RSD will be the standard in the future. Yeah, well, indeed, as Bill noted, rapid shutdown will become the standard for PV systems. We want to make sure that firefighters across the United States feel as though PV equipment is safe equipment, that they're not going to have to change their firefighting techniques in any substantial way to ensure that they get that fire out. And that's really what we're shooting for here. We want to convince and ensure that firefighters feel comfortable working around existing PV systems on roofs and can use their normal techniques for controlling that fire. Yes, I think that unless you're still under 2011 code, I think that you can indeed expect that you're going to have to install Rapid Shutdown with all of your systems going forward. If you are under 2011 code, there's nothing wrong with you. There's nothing wrong with retrofitting some RSD Rapid Shutdown devices, especially in the case of the Solis Rapid Shutdown device. There's no extra equipment to install, and so on the ground or beyond the box up on the roof, and so you can pretty easily comply with 2014, even though you're under 2011 code. We got a question about the Canadian Solar connector. And indeed, I've seen quite a few what they call MC4 compatible connections, and there are some jurisdictions that will allow this, but there are others that will not. And MC4, for example, is quite adamant that an ideal connection is between two actual MC4 connectors, and so it is our advice, and I think it would probably be the advice of our other presenters as well, that if you are going to use an Amphenol connector, that you use an Amphenol mating connector, and the same is true of MC4 and the Canadian Solar connector. If you insist, if you think that the MC4 is right, then you might even consider clipping off our MC4 connectors and putting a Canadian Solar one on the PV side of our RSD, so that you can get an excellent connection that you're not going to experience any series arcing through. And so that's your overall objective there. I'm sure that the connection is probably going to be relatively safe between a MC4 compatible connector and an MC4, but you run the risk of some small amount of arc fault or some issue there, and of course that's just going to cause you nothing but a callback. And so you have to weigh that in with any sort of advantage you get on cost with another type of connector. Well, I mean, we had a question here regarding the RSD and different string sizing. Indeed, the RSDs that we have today are a single channel where it's rated at 20 amps, and you can put as many, let's say, as two strings on there in parallel. And then we have a two-channel device that has a 10 amp and a 20 amp channel, and that so you can put as many as three strings in as you bring two strings down to your inverter. And so if you're going to be using four strings and you want to use four MPPTs, for example, which might be nice for optimizing your PV array output, remember that the MPPTs in the Solis inverters operate independently, so you can have different string lengths on each one. But in that case, for example, you would use two RSDs, and you would probably daisy chain the AC control circuit conductors from one to the other. So you just have one AC drop and four string drops down to the inverter. Regarding which distributors have the RSD, that would be AEE and CED Green Tech and Fortune Energy, and we just were here at the NABCEP conference, and the Power Store was over here. They had a booth, and they also do distribution of the product for us. Regarding stud finders, I think you can probably find that at Home Depot. Yeah, hammer and your ear is a nice way to go. I agree, Gail. That's the way we used to find them. Hey, everybody, I'll close this out now. Thanks again for attending. Really appreciate you spending the time with us today. We'll follow up with you and send a copy of the presentation if you'd like. And if you have any other questions for any of our presenters, please bring them forward. And thanks again for attending.
Thanks again, Terrence. And yeah, don't hesitate to contact the applications engineering team at SnapNRack if you guys have any questions about the application of the SnapNRack products. Thanks a bunch.
Thanks, Terrence. Talk to you later.
Thanks, Bill. Bye-bye, everyone.